the rod is moved with a constant acceleration. B is into the plane. So I'll give overall circuit. Circuit appears like this. And there's a rod PQ. B bar into the plane, here B bar into the plane. And this is moved with a constant acceleration E. Just now we have discussed the current, how the current here will be I1, this will be I2, the resultant current, this will be I. And this moving rod we can replace with a cell. The rod is moved with a constant acceleration. He's asking expression for current I. And there is a resistance of the rod also. So that I'll bring it here. The rod PQ is also having resistance. So what is the equivalent circuit? You can see now. So first, what is EMF? BLV. Then what is the velocity of the rod at any time? AT. The EMF. Then what is I is equal to? I should be equal to E by R plus R1 R2 by R1 plus R2. Suddenly why this equations of this kind? How R1 R2 will be? Parallel, no? That effect will become in series with this cell. You know enough of current density circuits. The moving rod will be like a cell. If the rod is having any resistance, bring that in series with that cell. Finish all. Let whatever the numerical know. It's a just current density problem, series, parallel, or any other conditions may come. Apply current density ideas. What is the Faraday's law? The moving rod, there'll be mostly EMF will be induced across the rod. The rest all everything is again you have to come to either the laws of like a magnetism or current density ideas. Now what is E further? This will be BL ET R plus R1 R2 by R1 plus R2. They'll ask you calculate the force. What about the external force that I should apply? F external minus BIL equal to ME. What is I? I is what you have to replace everything here. So B square L square AT by so look at the force, what I should apply, constant or time varying. A time varying force, we should apply it. So I suggest to students, every problem, please do analyze. In every problem, you're supposed to analyze. B square. In every problem, if it is moved with a constant speed, if it is moved with a constant acceleration, if it is given velocity, so all four cases is what you should analyze for each and every question. And also what happened to energy conversion. So the force acting should be a function of time, not constant force, should be a variable force. So what is a like an average force acted in an interval of time? Then what is work done by the force? They'll ask you. What about work done? How to calculate? Because force as a function of time, we don't have any formula to calculate the work done. No? What is the best thing? Look at acceleration, constant or variable. Acceleration is a constant or variable. It's a variable, no? Or acceleration is a constant. And at any instant of time t, you can calculate the velocity. Then change in kinetic energy of the rod is what? Work done. They may ask you the work done here. So for work done, what you should do? Take help of the change in kinetic energy of the system, or the change in kinetic energy of the rod, plus also heat generated. Yeah. See, yesterday I discussed, no, BIL force is something very important. What happened? The work done by BIL. The BIL force converts mechanical work into electrical energy, and that electrical energy will be converted into heat by the resistors. The role of BIL is different in different situations. If a resistor is there, it will convert mechanical power into electrical power. If capacitor is there, it will convert mechanical power into electrostatic power. It all depends upon the system. The BIL is having a major role here. BIL is what doing work. BIL is the agent which will convert energy from one form to another form here. Like a see, block, you give velocity and keep it on a rough surface. So after some time you come to rest now. Tell me like where that kinetic energy gone? Work done by friction. Tell me what friction did with that work? Friction is having any pockets, it will store nothing, no? So what happened? The work done by friction. Heat generated at the surface, at the contacts, heat generated on this ground and also to the block. That's what. So friction is what is doing now. It's converting mechanical energy into thermal energy. There is a role of friction. Getting so analyze energy aspect, it's very important because just don't end up with mathematical equation solving. The energy aspect in every problem you're supposed to analyze. So what is the role of friction here? It converts mechanical energy into thermal energy, and there'll be heat generated at the bottom of this block and also on the ground. Major will be taken by the block. It all depends upon again the type of surfaces here. The same thing role here. It's not a dissipative force, it's a conservative force. So just is